Hi everyone, you are welcome to Easy Science Channel 1, IL Excel Physics, WPH1101, January 2021, Part 2 of the Unit 1. Shall we start from the 13th question? A rugby player kicks a ball off the ground at an angle of 35.0 degrees to the horizontal as shown. The ball reaches a maximum height of 5 meters before returning to the ground. So you know now they are asking you to show that the initial speed of ball is about 17 meters per second. So we have to show 17 meters per second. Now you know this is he is kicking the ball at 35 degrees, and always when they say 17 meters per second, so you have to round it off to more than one significant figure. You should know that. So to get 17, show that. Now see, first of all you have to write all the data given. S is 5 meter, the distance, height, and U is, you have to resolve 35, decrease the U, so you have to mention the direction, so it is U sine 35. At the maximum point, you know, our velocity is going to be 0. Since we are taking upwards, it is minus G. Okay, so 9.81, so we want to find T. So what is the equation we are going to use according to this is V squared equals U squared plus 2as. So V squared we know U sine 35 squared plus 2 minus 985 into 5. So when you solve, you will get U as 17.27. You have to round it off to one significant, extra one. So that is 17.3. So see, it is about 17 meters per second. Always one significant more. That means it is U is about 17 meters per second. So I hope you understood. Now we'll move on to the B part of the question 13. After traveling horizontal distance of 22 meters, the ball reaches the goal. To score, the ball must be more than 3 above the ground when it reaches the goal. Deduce whether an initial speed of 17 meters per second is sufficient to score. So they are giving 5 marks. You have to look at the mark before writing. So 5 marks means 5 points. And also 5 minutes you can take. Time is roughly 5 minutes you have to take. So now see, you know, horizontal distance is 22. So DH is 22. So you are putting upward direction UT half AT squared. UH is 17 cos 35. So when you put like that, S equals horizontal direction, you know S equals T 17 cos 35, and that is 22 over T 17 cos 35. When you put upward, so U is sine 35, 17 sine 35, 1.58 minus half, is then you are getting S. Okay, so S is horizontally, it is 3.61. T is going to be 1.58. So now you know S is 3.61 you get, because it is more than 3. So the initial speed of 17 is sufficient to score the goal. Now see, you have to find T. Look at this. Look at the diagram. So here from here to here, the t and the horizontal t is same. Okay, so the first thing is you have to find the t, time taken, using u cos 35, because then you will find the t. That t is the same as the t we want in the vertical direction. So you apply that t and you will get the distance as 3.61, but they are giving more than 3 is whether we want to know whether it is equal. We can score the ball must be more than 3 meters above the ground. Yes, we are getting 3.61 meters. That means it is greater than 3. So the initial speed of 17 meter per second is sufficient to score the goal. Go to next question. Number 14. The photograph shows a fireboat used to put out fires on ships at sea. A pump fixed to the boat pumps water from the sea. The seawater is projected at high speed out of a pipe connected to the pump. So now I told you at the beginning, this is the diagram they are giving. So it is very easy to understand. So don't worry about the diagram. And you go and read the first part. A, the mass of the seawater pumped each second is 300 kilogram. The pipe has a diameter of 10 centimeter. Density of seawater 1030 kilogram per meter cube. So as soon as you see centimeter, you have to turn into meters. And when you see diameter, that is for you to get the R. So then and there, you work it out and you write down the paper. Show that the speed at which the seawater is projected from the pipe is about 37 meter per second. Round off to one more significant. So it is 4 marks. I have marked 4, so you have to give 4 points. In blue color, how do you get these 4 points? So previous question also, it's 5 marks. So I have these 5 points you need to write. That is how you get these 5 marks. So likewise, everywhere I have highlighted in blue color, then you know how you get 4 marks, right? So now 37 means you have to round off to one more significant figure. So that means now 37 meter per second. What do you understand? What do you mean by this? Per second 37 meters. So if you write 37 meters per second is right. That means you know t is 1, second 1. So when you put v equals velocity, distance over time, s length, so volume, v, another way of getting length is volume divided by area. You know volume is meter into meter into meter. Down area is meter and meter. So meter cube divided by meter squared will be meter. So this is another form of getting length. You have to remember. So we know the volume, we know the area. So density is m over v. So we can put, you know, m over density is your volume. So you can find the volume. You know area pi r squared. You know r. Then you can find a. So you know the length. So you know the length. So the speed will be 2.91 volume divided by area. So you get the length. So 37.1. Okay. So distance over time, because distance you know time is per second. So t is going to be 1. So v equals distance. So therefore it is 37.1. So we want to show that speed is 37. So it is almost 37. So when you, I hope you understand. So go to number 2. Second part. Determine the rate at which the momentum of the seawater is changed by the pump you may assume that the seawater is initially stationary. Okay, so now each second means t equals 1. So delta p, you know, momentum, change of momentum, mv minus mu divided by t. So you know m, you know v, and you know initially it is rest. So you will find 11,130. You have to put it in a standard form. So that is rate of change of momentum, kilogram meter per second squared. So you should know the unit. You have to mention the unit. Okay. Projecting B part. Projecting water from the pipe causes a force to be exerted on the pump. Explain the direction of the force on the pump. So projecting water from the fireboat exerts a forward force to the water. So due to the Newton's third law, water exerts an equal and opposite force to the pump. The direction of the force on the pump is backward. You know this. So you have to describe nicely. And C is initially the pump is turned off and the fireboat moves forwards through the water at a constant speed. The boat's engine provides a constant forward force. So you know backward force equal forward force means it moves at constant speed. When the pump is turned on, boat is projected forwards and the fireboat shows to a lower constant speed. Explain why the boat now has a lower constant speed. Your answer should refer to all the horizontal forces on the boat. So they are given 3 marks. So initially you should know the story behind this. When you read the question, you should understand what's happening. So initially what's happening? Drag force is equal to the forward force. Why? The speed is constant. So when the pump was turned on, what's happening? The resultant backward force increases and the boat slows down. So that means eventually decreases the drag force until the forces are balanced. As a result, boat has a lower constant speed. I hope you understand. Okay, it's clear. So move on to 15. Okay, so now question number 15, they have put an asterisk. That means you have to give writing. They are checking how you write. So in a bungee jump, the bungee jumper falls from a high platform while attached to an elastic cord. Cord is also attached to the platform. The cord slows the bungee jumper down so that he comes to rest before reaching the ground. The fall can be divided into 3 stages. Stage 1, the jumper is in free fall until the cord starts to stretch. Stage 2, the cord is stretching until the acceleration of the jumper decreases to 0. Stage 3, the cord continues to stretch until the jumper is momentarily at rest. Now see, they want you to write stage 1, stage 2, stage 3 alternatively. Now see what they are asking. Explain in terms of work done how the kinetic energy of the bungee jumper changes during the 3 stages of the fall. So it is given 6 marks. You should know what's happening. Okay, so stage 1, as the jumper is falling downward, what will happen? Kinetic energy increases. Why? He is accelerating. So only force acting on him is the weight. So here strain energy is 0 because cord is not stretched. So work done due to this work is done due to the gravity. Okay. When you go to stage 2, what's happening? The jumper starts to decelerate. And what happened to the kinetic energy? It increases at decreasing rate. Remember, not as fast as stage 1. Okay? As the code is stretching, there is an elastic potential energy now. So the work is done by the code here. But when we go to stage 3, what's happening? Kinetic energy increases and acceleration has stopped. So now jumper momentarily comes to rest. Why? Because work done by gravity equals work done by the code. Okay? So I hope you understand what I said and it's clear for you, and that will be the end of the part 2 of the unit 1. I think all of you understand very well. Thank you very much. See you in next video, part 3 of this paper unit 1. Until such time, study well. Have a nice day.